This video is for Chapter 10, Section 6, and it's all about arcs and circumference. A lot of what we're going to see in this video are things that we've already talked about, but we want to really define them and get to this final stage where we can find the length of an arc of a circle. So, let's first start off by defining a circle. By now we should understand that a circle is a set of all points equal distant from a point called the center. A circle is named by its center. For example, circle P. If there was a distance of, say, 5 inches, then this represents all points that are 5 inches away from the center. We drag out 5 inches, 5 inches, 5 inches, 5 inches, 5 inches. They are all the points that are exactly the same distance away from the center. Now, here's a larger circle in which we're going to take a look at the parts. The distance that we're talking about is called the radius. A radius is a segment with one endpoint on the circle and one on the center, from center to circle. And the radius length never changes. All radii of a circle are congruent. It's that 5 inches we were talking about. Okay. Then there's the term diameter. A diameter is a segment going through the center of the circle with both endpoints on the circle. It is important to remember that a diameter is equal to 2 times the radius. This is something we will use later when we look at the formulas involving circumference. So a diameter is 2 radii that are collinear with each other, going through the center of the circle. Okay, next we'll talk about central angles. So a central angle is an angle whose vertex is on the center of the circle and the endpoints are on the circle. Angle DOG would be a central angle. One key note before we move on, you may want to write down, all central angles add up to 360 degrees if we go around the circle. Okay, next we're going to talk about an arc. An arc is not really defined in words, but more just the idea that it is a part of a circle. For example, from D to G would be an arc. It's not a segment because it's not straight. Now, there are 3 types of arcs we're going to look at. First of all is the semicircle arc. A semicircle is half of a circle. Now, we're not talking about arc length at this moment, but rather arc measure. The measure of the arc. Okay, so this is not the length of the piece of string going around from here to here, but just the measure of the arc is 180 degrees. Measure is always in degrees, and since it's half of a circle, half of 360 is 180. Now, the other important thing is that we always name a semicircle with 3 letters. Arc T, V, R. T is the start point, R is the end point, and V tells us what direction we're going. From T to V to R. 180 degrees. Now, this is the middle arc. There are arcs that are smaller than a semicircle and arcs that are larger than a semicircle. Our names will be, first, minor arc. A minor arc is less than 180 degrees. The measure of the minor arc is equal to the measure of its central angle. So, for example, here we have a 50-degree central angle. So the measure of arc RS would be 50 degrees. We may want to write 50 degrees right here on the arc. So, the measure of a minor arc is equal to the measure of its central angle. 50-degree minor arc, 50-degree central angle, 50-degree minor arc. Notice the minor arc is only labeled with 2 letters. You should write that down. Minor arc, 2 letters. That is how we know it's a minor arc. And what it means is to go the shortest distance, R to S. Not R to S. That would not be a minor arc. So what would that be? That would be a major arc. A major arc is one that is greater than 180 degrees. My example in this picture is arc TRS, from T to R to S. Now how do we know we go that direction? Well, if it was TS, well, we can't go TRS. See, we have to hit the letters in order. T, R, S. And I know it's 230 degrees because I'm going to combine my semicircle plus my minor arc. 180 plus 50 equals 230 degrees. Now, let's go back to that minor arc, RS. We could say major arc, RTS. And that would be a major arc, R to T to S. Now the measure of arc RTS is going to equal 360 minus 50 degrees, so 310 degrees. There can be a lot of different ways for us to figure out arcs. There's another minor arc in this picture, S to T. That would be 180 minus 50 degrees, so 130. Here's a 130 degree minor arc. Here is a 310 degree major arc. All the arcs are based on the circle being 360 degrees. And last, again, I'm going to say the measure of an arc is in degrees. Semicircles 180, minor arcs less than 180, major arcs more than 180. Minor arcs 2 letters, major arcs 3 letters. So that's going to be it for arcs and the definition of circles. So central angles, minor arcs, major arcs. We're now going to move into circumference and arc length. So circumference. First, quick note, what is pi? Pi actually represents a ratio between the circumference and the diameter. If you take the circumference of a circle and divide it by the diameter of the circle, the ratio will always be pi. Now, if we multiply this equation on both sides by d, we can see that circumference equals pi times d. But let's remember, d is equal to 2r. So circumference equals pi times diameter, or circumference equals 2 pi r, because d and 2r are the same thing. So here are 2 circles that lie on the same plane and share the same center. These are called concentric circles. One interesting thing you could do with concentric circles is figure out, well, what would be the circumference of the yellow circle compared to the circumference of the blue circle? Well, it appears the blue circle has a radius of 16.1. So circumference equals 16.1 feet. And we could say that radius equals 16.1 feet. So the circumference of the blue is equal to 2 times pi times 16.1. We take our calculator for this and we say 2 times pi, and here's the pi button, times 16.1. And we end up with 101.2. So I have 101.2 feet. That is the circumference of my blue circle. Let's look at the yellow circle. Well, for the yellow circle radius, we're going to have to take that 16.1 and subtract 4.7. So we take 16.1 and we subtract the 4.7, and we have a new radius of 11.4. So my circumference of yellow is going to be 2 times pi times 11.4. Now I take 2 times pi times 11.4, and I've got 71.6. So we can find the difference in circumference between yellow and blue. Even though they are concentric circles with their center in the same spot. I like to think of this as a car driving in a circle. and the outer tires are going to move 101.2 feet, and the inner tires are only going to move 71.6 feet. So that's a brief look at circumference. Let's move on to arc length. Okay, arc length. We already know we can find an arc measure in degrees. It's out of 360. But we can also find an arc length that is just a fraction of the circle's circumference. For example, look at this picture here. Arc VZ is 90 degrees. Okay, we can see that arc VZ is 90 degrees, which represents 1/4 of the circle. Well, this circle has a radius of 12, so I think I could find the circumference of the circle, the length all the way around. Well, then the length from B to Z would just be 1/4 of that. So the circumference is 2 times pi times radius, so that's 24 pi. We'll leave it like that. And the arc length from B to Z, not the arc measure, the arc length is 1/4 of 24 pi. So 1/4 of 24 is 6 pi. Now this example helps us understand how to find arc length. We're going to take an arc's measure as a fraction of 360. 180 degrees out of 360 would be half the circle. 90 out of 360 would be 1/4 of the circle. And then we're going to use that fraction to find the amount of the arc length. So the equation becomes the measure of the arc divided by 360. 90 divided by 360 is 1/4. That becomes the fraction of circumference, 2 pi r. Fraction, measure of the arc divided by 360 times 2 pi r. And this is our arc length formula. We'll take a look at a couple quick examples and be done. Fraction of circle times circumference. Okay, so let's take a look at this first example up on the board, and let's try to move through these quickly. So, find the arc length of arc AB. Well, arc AB's central angle is 120. So, for my AB arc, I'm going to take 120 divided by 360 times 2 times pi times 15. Well, 120 over 360 is 1/3. 2 times 15 is 30 pi. And 1/3 of 30 pi is 10 pi. Now, if I want the exact answer, then I'm done. My arc length is 10 pi meters. Now, if it says find the arc length of ACB, which is the major arc, that would be the rest of the fraction. So 360 minus 120 is 240. So if I want ACB, I've simply got 240 over 360 times 2 pi times 15. This is 2/3 of 30 pi, which becomes 20 pi. So the smaller arc, 10 pi, the major arc, 20 pi, together they would create the entire circumference. There's example number 1. Hopefully we've written this down. Let's look at example number 2. Find the length of arc CDE. C to D to E. Well, CDE, that's a semicircle. CDE, I don't even have to write 180 over 360. It's 1/2 of 2 times pi times the radius. Well, the radius is 8. In this case, I can see right here the 1/2 and the 2 cancel out, and my answer is 8 pi. Exact answer, and we're done. If I want CD, well, CD represents 90 out of 360. We're going to pretend right now that there was a right angle symbol. Hopefully I can get it in here. Right there. So we see this as 90 degrees of 2 times pi times 8. So this is now 1/4 of 16 pi. 16 divided by 4 is 4 pi. And notice it is half of a half. 8 pi was half the circumference. 4 pi is 1/4 of the circumference. No problem there for our first two examples. Now our last example is going to be round to the nearest 10th. So we're going to take the arc length of xy, xwy. First of all, we need to figure out what fraction out of 360 it is. X to w to y, well how about wzy is 180 plus 45. So I have 180 plus 45, which ends up equaling 225 over 360. Now it would be nice to use our calculators and be able to figure out what fraction that is. Most calculators will reduce it to 0.625, but we should learn to use the fraction button because this is actually 5/8. And then we put 2 pi r, and the radius in this case is 4.1. So I have times 8.2 times pi. Now all of this, if you put it together, is 5 divided by 8, that's that 0.625 number, times 8.2, and then I multiply that by the value of pi, which comes out to approximately 16.1. So 16.1, and it becomes units, which is feet, and there is my final arc length. So there was a lot in that lesson right there, and quite a few examples right here at the end for you to use. You now know what a minor arc is, a major arc, and a semicircle. Arc measure is in degrees. Then we covered circumference, 2 pi r, and we used the fraction of a circle multiplied by 2 pi r to give us arc length, which was the major ending point for this lesson. That's it for chapter 10, section 6.